Hello all, welcome to Life Science Library. In this video we are going to see about previous year questions from Animal Physiology, Unit 7 CSIR Net Life Science portion. Along with the previous year question, we are also going to do the concept related to it, especially from the part of nervous system. So what things we will be seeing in this video? We will be dealing with all the questions from nervous system, and it includes the year of 2006 to 2016 CSIR net and IASC questions. It will be useful for CSIR net and GATE life science students. First, a question from June 2015. In which of the following condition basal metabolic rate are lowest? So, BMR is the basal metabolic rate. Basal metabolic rate will be lowest during sleep. C is the right answer. Next, question from June 2014. When a skeletal muscle with an intact nerve supply is stretched, muscle contracts and increases. Which of the following statements are correct? We are going to find the correct statements. Golgi tendon. We have seen yesterday about Golgi tendon, where the muscle and bone get attached. If they are stretched, Golgi tendon will have a role. So this can be a possible option, but let's wait. Next is about gamma motor neuron and alpha motor neuron. So we will see quickly about both things. What are motor neurons and about alpha and gamma motor neuron. Motor neuron are of two categories. Motor neuron have motor functions, physical function. They are of two categories, that is alpha motor neuron and gamma motor neuron. Alpha motor neuron, they are present in extraphyseal locations and they are mainly concerned with contraction. Gamma motor neuron, they are present in intrafusal condition and they function with less contracting ability. These are the two major functions of alpha and gamma motor neuron. Now coming back to the question, gamma motor neuron were excited when stimulated by afferent nerve fiber. So, stretching ability of gamma motor neuron is little less when compared to alpha motor neuron. So, B can't be the correct answer. B option is eliminated. Muscle spindle was stimulated by stretching. Muscle. This is a correct statement. Alpha motor neuron was excited by stimulation of afferent nerve fibers from stretching. This is also a correct statement. So C is the right option. Even though A is not right. A has a role in stretching. Next question from June 2014. Mechanical pressure was excited on the specific location of peripheral nerve of mammal. Touch or pain receptors. Yesterday we have seen about touch and pain receptor. Touch receptor is associated with fiber A. Pain receptor associated with fiber C. So, were stimulated from the skin surface intervened by the same nerve. Action potential generated by the touch receptor stimulated was blocked beyond the point of mechanical pressure. So, mechanical pressure is being given wherein this touch receptor is blocked. but the action potential generated by the pain is normal. So which is affected? Touch is affected. A is affected. This statement is saying that A is not affected. So D can't be the right answer. A is affected. Touch is affected. So A and B is the right answer. Next, a question from December 2014. Let's try and answer this question. When a nerve fiber is stimulated with increasing strength of stimulus, action potential failed to generate, even though threshold level is passed. Which of the following statement may explain the accommodation of nerve fiber? Even if though the action potential was passed, critical number of sodium channels should be opened. If that is not opened, action potential will not occur properly. Then, potassium channel open in response to slow depolarization, which makes the nerve fiber refractory. What is refractory? Refractory is nothing but we are giving a stimulus 1. We are giving a stimulus 2. Okay. So what is refractory period? What is refraction? Consider this as a nerve fiber, neuron. We are giving a first stimulus here. We are giving a first stimulus. The stimulus is generated. Half the stimulus generation is done. We are giving a second stimulus again here. So this stimulus will not be propagated. There is a defined period of time between the first stimulus and second stimulus. That period is called as refractory period. So, potassium channels open in response to slow depolarization, which makes the nerve fiber refractory to depolarization. Okay. Next option. Low threshold sodium channel remain open, which increases the threshold firing. So we are not speaking about the firing of action potential. Action potential already is not fired. So C can't be right answer. Efflux of sodium and influx of potassium due to operation of Na plus K plus ATPase oppose depolarization. This is absolute wrong statement. D is wrong. Potassium channels open in response to slow depolarization. Okay. Which makes nerve fiber refractory. So A and B can be the possible right answer. This question we have seen. Now we are going to see another question from CSIRnet December 2014. Nichrome coated stainless steel electrodes were implanted in the brain of rat. Consider this as a brain of rat. Nichrome coated electrodes were implanted into rat brain. For chronically recording the electrical activity of deep brain structures, during a study of 3 months, the intensity of electrical signal gradually increased. Following statements may explain the cause of observation. Deposition of metallic ion from the electrode tips causes degeneration of some neurons. This is correct statement. Gradual accumulation of microglia at the electrode tips increased the resistance to electrodes. This is correct statements. Neurons at the electrode tips were hyperpolarized. This is a wrong statement. C is wrong. A and B are the correct answers for this question. Threshold for firing action potential in the neuron at the electrode tips was increased due to the prolonged presence. No, this is not the correct. These are the two learning. What will happen if electrode is placed in the brain? Next, a question from December 2013. Again, we are going to see about refractory period. This time we will see in detail about refractory period, refraction. Refractory period are of two types. That is absolute refractory period and the other one is relative refractory period. In absolute refractory period, between first stimulus and second stimulus, there will be an empty gap. There will be a left time period called as absolute refractory period. In this period, there can be no stimulus. In relative refractory period, consider this as a gap between two stimulus. If the threshold is given with more powerful stimulus, then we can expect a small amplitude of action potential. Large amplitude of action potential will not be seen only if there is a strong stimuli. Now coming back to this question. Action potential was generated on the nerve fiber by a threshold electrical stimulus. When a second stimulus was applied, no matter how strong it was, during the absolute refractory period of an action potential. Now we have seen this. Nerve fiber was unable to generate second action potential. This observation was explained in the following statement. Large fraction of potassium channel was voltage inactivated. No, it's not potassium, it is actually sodium. Going to find true statement. Critical number of sodium channels are required to produce the action potential that could not be recruited. No, critical number of potassium channels are required to produce the action potential that could not be recruited. C and D are the correct statement. D is the right option. With reference to refractory period and how the relative refraction occurs. In case if the stimulus is given during the refractory period, what happens? This is the third point we are going to see about refractory period. So, action potential leaves Na plus channel inactivated. Action potential leaves Na plus channel inactivated and K plus activated. Okay. So, during this refractory period, Na plus inactivation, K plus activation. So, critical number of potassium is required. So, C and D is the right option. Other things are not correct. C and D is the right option. Next, about electroencephalogram. An electroencephalogram was recorded and its power spectrum analysis were done in rats with implanted electrode for a long time. Power of electroencephalogram waves decreased 2 months after electrode implantation. This observation may be due to following things. So initially we have seen in recording spectrum analysis were done in rats with the implanted electrode for a long time and the power of EEG waves decreased. We are going to see why it is decreased. This is the meaning of this question. We are going to see. Select true options. Glial cell accumulate in the surrounding tips. Correct. Degeneration of neurons occur in the surrounding electrode tips due to metal ion deposition. Correct. A and B is the right option. Coating of electrode destroyed with time. No. Microsocket becomes loose. No. So other statements are wrong. A and B is the right answer. B is the right answer for this question. Next, about learning. We have too many learning in this question. Which part of brain is involved in motor control. So what is motor control first of all? Motor control is nothing but muscle functions, muscle movements, skeletal movements, your complete physical movements. This is motor control. Motor control is preferably by cerebellum. So what do amygdala do? They respond to threat stimulus. Threat. When any animal, when a lion comes in front of you, threat stimulus get generated, amygdala get generated. Then what do hippocampus do? Hippocampus help in learning and memory. You are learning this thing, nervous system, you are memorizing too many things, too many formulas, equations. So hippocampus has a role. Where this hippocampus and amygdala is located? They are located in temporal lobe in the brain. What is the function of prefrontal cortex? They are help in cognitive functions. So the correct option for motor control is cerebellum. Now this is a challenge question asked in challenging question. This सवाल है सवाल challenging सवाल है IISc Bangalore question, that is, transmitters are inactivated at the synapse by all the following mechanism except. Without thinking, this is the answer, but I need explanation in comments. Pause this video, go to comments and explain why this is correct. Neurotransmitter can be inactivated generally by two mechanisms, by employing some enzymes to destroy the neurotransmitter. Second method is by reuptake and uptake. Reuptake. So comment below why it is correct. Correct me if this is wrong. If this option selection is wrong, see to it whether this is correct, this is correct, this is correct, or this is correct. So answer this question in the comments below. This is a homework question for all the viewers. Information is coded in the nervous system by frequency of action. This is a IISc Bangalore question. First, next about neurotransmitters. This we are studying right from childhood. So what is an excitatory neurotransmitter, inhibitory neurotransmitter? We have two different classifications in neurotransmission. One is inhibitory neurotransmitter and another is excitatory neurotransmitter. Inhibitory neurotransmitter, we have GABA, gamma aminobutyric acid. We have glycine. We have serotonin in the function of neurotransmission. These are inhibitory neuro. We also have acetylcholine in both inhibitory and excitatory, but mostly excitatory functions of acetylcholine is concerned. So acetylcholine comes in an excitatory neurotransmitter. We have both things. Muscarinic in inhibitory and nicotinic in excitatory. So dopamine in excitatory neurotransmitter, glutamic acid in excitatory neurotransmitter. Okay. Coming back to this question. IISc Bangalore 2011. Inhibitory interneurons in cerebral cortex. Which of the following is a neurotransmitter? We are speaking about inhibitory interneurons, inhibitory neurotransmitters. Which is an inhibitory neurotransmitter? Most probably in cerebral cortex is gamma aminobutyric acid. Anterograde degeneration can be defined as nerve transaction leading to anterograde. It's not retrograde, it is anterograde. So consider this as a nerve, neuron. This is end plate. Here we have nodes of Ranier, myelin sheath, whatever, what's not, whatever things. Anterograde degeneration is degeneration in the end part of nerve fiber. Degeneration occurs in the end part of nerve fiber. The distal nerve degeneration. Next, which of the following cell types listed below form myelin sheath of neuronal axon in the central nervous system? This is a pretty much straightforward question. Maybe in the part B section we will be expecting such question. IAC Bank in 2011. The answer is Schwann cells. Now, a question can arise here. Gamma aminobutyric acid is also an inhibitory neurotransmitter. Serotonin is also an inhibitory neurotransmitter. Acetylcholine have both a function. Which is the right option? In case of cerebral cortex or with reference to central nervous system, inhibitory neurotransmitter straight away mark gamma aminobutyric acid. This is a universal truth. This is bonus question from Life Science Library. This is a bonus question. Fatafat, try to answer this question. Action potential results from. How action potential generated by depolarization, by opening of voltage gated Na plus channel. Next question. Simple question from electron encephalogram. It is an electrical stimulation of nerve bundle maintained in temperature. This is temperature T1. 37 plus or minus 10 degrees Celsius showed ABCD peaks. When recorded at the distance of 15 cm from the stimulating site on the same bundle. Same experiment was conducted in lower temperature, that is T2. Think what will happen. If more temperature is given, we can see so many peaks. If the temperature is reduced, stimulation is reduced, so we never be seeing these two peaks. Answer is not show peak D, may not show peak C, but show peak A and B. This is bit logical. Next, from June 2013. This is an experimental based question. Action potential was recorded intracellularly from a squid giant axon bathed in two types of fluids such as seawater and artificial salt water. Now, condition 1. Having low concentration of sodium ions while maintaining the same osmotic pressure with acetylcholine. This is a condition of artificial water. So, what is the most likely to be the answer? The resting transmembrane potential was not changed, but the amplitude of action potential was increased with lower sodium concentration in the bathing fluid. Amplitude of action potential was gradually decreased with reduction in the sodium concentration in bathing fluid, but duration of action potential was prolonged. This is the right statement. This is not right. This is not right. This is not right. B is the right answer. 161, we have seen that. Now, this question from Bangalore IASC 2013. Nerve contains axon of different types. Velocity of action potential propagated will be highest in the thick myelinated axon. This is basic question. Very, very basic. Now, from June 2007. Among the following, which of the following is responsible for nerve action potential? Bilkul. Fatafat, try to answer this question. So, Na plus 3 Na plus comes in, 2K plus goes out, that is Na plus K plus ATPS, the influx of Na plus ion and outflux was K plus ion. This is the right answer. This is an experimental question. Electrical stimulation, we have two given statements and we are asked to find the correct options. Electrical stimulation of an area in the brain A increased the function F, which was prevented by systemic injection of adrenergic antagonistic parazosin, injection of carbastrol, cholinergic agonist, into A increases function F, which was however not prevented by systemic injection of adrenergic antagonist parazoin. So what can be the probable reason? Pretty much simple question. We have reactions when adding these two things. Antagonist of cholinergic, adrenergic, whatever, we have a different reaction. Means both neurons and fibers are involved. This question we have seen. Try this question. December 2011. Nerve impulse of action potential is generated from the transient changes in the permeability of axon membrane to Na plus and K plus ions. Depolarization of membrane beyond the threshold level leads to Na plus flowing into the cell and change in the membrane potential to positive value. K plus then opens, allowing K plus to flow. This is the what resting membrane potential. Na plus and K plus move in the opposite direction just because this is straightforward question. Part without reading option, you can see that part B is the right answer. This is easy question. There is a difference in Na plus and K plus concentration in either side of membrane. That's why there is an gradient created. When neuron is at the resting potential minus 70 MB, the net flow of sodium ion is. This is resting potential and there is no stimulus. So movement is 0. Because sodium ion does not move across membrane. This is the right answer. This is an interesting question with respect to refraction. Amplitude of neuronal action potential will be smaller if nerve stimulus during the relative refractory period, nerve stimulated during relative refractory period, or extracellular Na plus calcium. No, this is wrong statement. Resting membrane made more negative. Wrong statement. Stimulation intensity is increased. Wrong statement. This is correct statement. We know what is relative refractory period. Try correlating this with that. December 2010. There is a small gap between two neurons. Consider this as a neuron 1. This as neuron 2. Okay. There is a small gap between these two. Why? Because of unidirectional flow of information. Try answering this question. We have two types, that is neuropeptides and neurotransmitters. Which of the following statement is correct about neuropeptide? It is more potent but long lasting. This is new learning for us today. Now again, an experiment based question from nervous system. Consider this as a neuron. Try to consider this as a neuron. Okay. Viewers. Okay. We have end plate. And I am drawing a stimulus. So where the action potential will be generated? It will be generated in this direction or this direction. It will be generated in both the directions. It will be generated here. It will be also generated here. Nerve impulses are traveling in both directions opposite to each. This is the correct answer. Next, December 2012. Muscle tone was increased after electrolytic lesion from caudate nucleus in rat. Muscle tone decreased within 7 days. Which is the following explanation given are correct? Once increase, then decrease, because it is said that it is a basic understanding without any prior knowledge from nervous system that there is a recovery. Okay. First option, it is said that functional recovery was due to plastic changes. There is no any plasticity change in nervous system. Brain tissue surrounding the lesioned area was not functional due to circulatory insufficiency. Immediately after surgery, which leads to greater loss. Circulatory status in surrounding tissue recovered with time, resulting in the partial functioning of record, that is decreased function. B and C is the right answer, D and A is the wrong answer. B is the correct statement. Same question, okay. Now, on 82 question of electrocardiogram. This is from cardiac system. ECG. This is a simple school question. T wave represents ventricular repolarization. C is the right answer. Which structures involved in the emotional content? It relates with emotions. We have seen already all these statements. Amalgida relates with emotion. So we have seen this question already. Now, 224 question, IISc Bangalore. Speed of action potential to the nerve fiber can be increased by increasing stimulation. We have seen that myelinated neuron will send the signal faster than unmyelinated. So it is an insulation. Insulation will increase the speed. Presynaptic and postsynaptic cells are incubated in Na2 plus free medium. Then what will happen? So in neurotransmission, in synaptic transmission, Ca2 plus is involved. Ca2 plus involved in stimulation and production of neurotransmitters in synaptic vesicle. It will consider this as a neuron 1. As neuron 1, we have an end plate here. Consider okay, I am so sorry for the bad diagram. Consider this as a neuron 2. If there is a stimulus here, stimulus will generate and it will, what happens here? And it will stimulate Ca2 plus ions. Ca2 plus ions will produce stimulation of neurotransmitter. They are released in the synaptic vesicle and they will attach into the postsynaptic neuron. This will happen. So calcium 2 plus in the presynaptic is not disturbed even if they are placed in the calcium 2 plus free medium. So the answer will be membrane depolarization of presynaptic cell could not take place. This is a wrong statement. D is the correct statement. D is the right answer. This question we have seen already. Now we have reached the end of the session. At the end of the session, we have seen about all the questions. Hope this session becomes very, very useful for CSIR Net Life Science students who are appearing for upcoming CSIR Net Life Sciences exam GATE and ICMR exams as well. Any kind of life science examination, even for NEET people as well. This video gives a complete explanation about all the critical and important matter and experimental analysis of all the questions from CSIR Net Life Science category. Now the left topics. बाकी topics है. We should see in details of neurotransmitters of the presynaptic ganglionic neuron. That thing is a baki. Next thing we should speak about sensory fibers. Next we should see about baroreceptors. These three things are left. Other than these three concepts, we have seen all the questions in these two phase of videos from Life Science Library channel. With regard to nervous system, we have seen all the questions 2006 to 2020, all the questions plus IASC Bangalore questions as well, and a practice question from Life Science Library. This is an important material for all the students. Hope this video is very important and very useful for all those people who are preparing Unit 7 System Physiology Animal. And please do refer this channel with your friends and fellow aspirants. Please do like, share and subscribe this channel for more videos and contents from our side. Thank you for watching this video. Thank you.